About 4 minutes ago, this was all empty chairs. So I'm very impressed in how this happened. Like, did they just go and get people out of the street and say, fill the chairs or something like that? No, nothing like that, nothing like that. It's an honor to be here, and thank you, Paul, for the kind and short introduction. I hope to allow some time during the talk for Q&A and stuff to get people's insights and opinions and stuff like that. But the chat today is about what I call reality-driven testing. I'm not trying to invent a new driven. Frankly, I'm driven to confusion with all these acronyms with the word driven in it. There's something like 25 different acronyms with driven: test-driven development, behavior-driven development, example-driven development, acceptance test-driven development. And these are all, by the way, real and confusing methods that cause things. So I'm not trying to invent a new one. I'm trying to actually suggest here that maybe we can sometimes try to make things real. And I jump up and down when I say this, but I'm so tired right now, I don't know if I can jump up and down, but let me try. I'm mad as hell and I'm not going to take this anymore. I am sick and fed up with the whole notion of people doing ticket-driven testing. Have you ever seen that? Have you ever got a JIRA ticket and said, test this? Have you ever heard of an object that has a state that said it's not ready for test, and now it is ready for test, and now it's not ready for test anymore, and now it is ready? This is an amazing thing. I run into companies, I did task analysis all over the world. I'm telling you, with my McGill students, we're doing something like 400 different cases a year that we're looking at. And I'm seeing all sorts of crap related to testing tickets. I have a customer with 920 automated scripts to test tickets. Who buys tickets? Is this like for the bus company or something? Why are there all these tickets? And of course, it comes down to the workflow model is driving the testing. And the workflow model is just a state model tool. It's just a cool, fun tool that helps you organize yourselves. But in fact, what was I talking about? In fact, it's just a model. The tool is just sort of to help steer your project a little bit. None of your customers are actually buying these tickets. They're not buying the tickets, they're buying a product. And when you're testing a product. The ticket might sort of suggest something about why you might need to be doing some testing on it, but it's not the reality of your work. So I try to, among that community of people, I'm trying to help make it real. And that's why I call this reality-driven testing. I want people to think, what is real? What are we really doing here? And I praise JIRA. I praise JIRA because I was a champion of JIRA as early as 2000. And I was an advocate of it. It was the first workflow management software that I saw in software engineering that was both loved by programmers and testers alike. And that was a huge transition. That was a huge transition, and it created an enabled collaboration like we'd never seen before. So I don't want to say anything against ticket management systems. I just want you to realize it's a model to help manage your project. It is not what you're testing. So let's talk a little bit about reality. Me, yep, that's me. That's me again. 2 pictures, me, yeah. Philosophy, all right. So I'm mad as hell, that's the pain. I think that we have serious concerns in this field that are not going away, but are sort of, I guess the beautiful problems is that we have not enough time. Do you guys have enough time to test? Not enough time, not enough budget, not enough money. I did a just-in-time testing workshop yesterday. We had a collection of pain points, and then I contrasted it with a collection of pain points I've been making, and they're the same pain points over and over and over again. We don't have any time. The requirements are changing. The goals are changing, and they're going to pull the rug from under us whether we test it or not. So let's figure out a way to figure out what to do. So we're basically confronted with these type of pain points. And in testing, I like to suggest that we can't ever test everything. You can't test everything. So we have to make trade-offs. We've got to figure out a little bit about how to know when it's been enough. Have we tested enough? So how do we know we've tested enough? How do we know we're finished? And I know Paul and I, we've got young kids. We used to have young kids. Now they're old, but they still do this to me. They still do this to me. They ask me this question, and this is the question for Rob. It's, are we there yet? Are we there yet? We're driving from Montreal to Ottawa. That's about a 200-kilometer drive. Start driving. The kids, are we there yet? Are we there? We didn't get out of the driveway. How could we be there? And then you get to the border of Quebec and Ontario and say, well, we're not there yet. And then you get further and further. Eventually, you get there, and they've asked you 4,000 times, are we there yet? Now, they are actually training to be project managers. This is the key thing. But are we there yet is the fundamental question for me in all of software engineering. All of software engineering. Are we there yet? Have we got something that offers and delivers a value proposition to our stakeholders that'll help us survive another day? Are we there yet? And there's a lot of perspectives on this, and I would suggest that maybe testers, to make things real, should know how this question is answered before you start. And I don't want to prescribe an answer. I don't want to tell you how to answer this question, but I want to suggest that if you don't know what the answer to this question is, maybe it's too early for you to start testing. Maybe just because the ticket says the thing is ready to test doesn't mean that it's actually time to start. There's also another notion that comes up. I think you've heard this term before. How many people have heard the word quality before? Only 3 of you. 16 of you. Okay, most of you. In the history of the field, we've actually had times when people use that word in job titles. Does anyone here call themselves a QA person or a QA, a quality engineer? Some of you. So this is a big thing. Before I start testing, I like to know what is quality. And as with most other things, it doesn't really matter what Rob SABOURIN thinks quality is. It matters what my stakeholders think quality is. And my job is to learn that. So learn to make things real. I've got to understand what my stakeholders believe quality is. It's not what I believe it is. I don't want to impose my view of quality on other people. This is one of the reasons why I get a little agitated when people start calling themselves quality coaches. And I said, okay, well, maybe you should be a quality listener a bit before you start telling people what it should be. Listen, learn what it is. And it's not a slogan. So many people think quality is like Ford Motors, Job One, all this stuff. It's not a slogan, it's a reality. And to learn quality, you really got to watch people make tough decisions and learn how they make tough decisions. And that's what you're going to see your stakeholders care about. So there's a lot of different views of it, and before I start testing, I want to make it real. I want to understand what is quality to my stakeholders. And I know that there's a lot of different opinions and philosophies about what is quality. But I want to suggest here that if you interview enough people, you're going to narrow it down to about 3 categories. Maybe there's more. I don't want to say this is a generalization, but one view of quality is from the TQM, the Total Quality Movement, very popular mid-'80s to the late '90s. Phil Crosby was the champion of that, and it was that quality is conformance to requirements. Anybody have that view of quality in their company? Show of hands. Quality is conformance to requirements. This was the dominant view in most of my career. Today it's not as popular, but still was dominant. Another view, dating back to 1950 by Joseph Juran, quality is suitability to purpose. This is very popular among the behavior-driven universe of agile practitioners. Quality is suitability to purpose. It is not conformance to requirement. It doesn't matter what the software is required to do. It matters that the user can do what they need to do with the software. 2 sides of the same thing. Very different testing from a different definition of quality. Anyone have suitability to purpose? Quality is suitability to purpose. A lot of people have that one today if you're doing BDD-ish type of work. By the way, not all agile people would associate themselves with Joseph Juran, but I have to tell you, that's the origin story of that. That's 1950 Quality Control Handbook. And the other one in this list is I'm going to quote it through Jerry Weinberg, but there's also Tom Gelb, the famous pioneer in software engineering, had a very similar definition. Quality is value to stakeholders. This one, some people say, is very modern, inclusive definition of quality. Does anyone have that one among their stakeholders? Quality is value to stakeholders. A lot of you guys have that one. And that one is really cool. It's a nice one. It's a fun one. It's like hip, right? We are the generation of modern, hip, quality people. But unfortunately, if quality is value to stakeholders, what you've got to do as testers before you start, before you dive in, just because that ticket said go, you got to understand, in my experience, the notion of who is the stakeholder and what do they value. Who is the stakeholder and what do they value? And guess what? That's not static. That is time variant. So when I walk in the morning and I open the door and I come in, I have to ask the question, and this is to make it real, what business are we in today? What matters today? Is it the accounting department because of my travel policy, for example, that's driving my decisions? Or is it my product manager? Or is it sales? Or is it the fact that we have to eat and we need revenue? Different things matter to different stakeholders. Your job is to identify who are stakeholders and what do they value before you dive in. So that's sort of making it real. Our field is a new field. Our field is a new field. Software testing is a relatively new field, although I would want to suggest that, I don't want to get distracted, but test automation, software test automation, predates digital computing. My dad worked for Northern Electric in the automated test set maintenance department in the 1940s. He programmed the tape-o-matic test set from Western Electric, which did automated testing of telephone switching circuits in the 1940s, predating digital computing by about 7 years, modern digital computing. So automated testing of systems, autonomon, real computing systems, predates digital computing. But that's beside the point here. I like to talk about the history. That's still new. That's not, what, 60 years, 70 years? It's not 2,000 years. In civil engineering and architecture, there's a book called Vitruvius, which was written at 25 BCE and is still actively referenced by people in the civil engineering and architecture community. They've got 2,000 years of documented practice, which is also evidence-based practice, and they're still learning new things every day in that field. 2,000 plus years. And if you go back to the practice of civil engineering and architecture, can go back to go to ancient Egypt, look 5,000 years ago. They had incredible architecture projects and civil engineering projects. The field is about 5,000 years old. Now our field, of course, we're lucky too. We have that same sort of thing. Our Vitruvius is The Art of Software Testing. How many people have a copy of this book? These are the brave ones. These are the people who know the history of our craft. That's actually the first book on software testing, at least the first one that explicitly teaches software test design. I didn't ask how many people read it. I'm assuming that none of you read it. It's just a pretty orange cover, right? That's attractive. No civil engineers actually read Vitruvius, but they reference it a lot. That's a nudge to the speakers here. So The Art of Software Testing by Glenford Mayer was written in 1979. So we have, 40-something years ago? And that's how much documented history we have. A little bit of evidence. There's still no generalizations. We don't have any basis for templates or general solutions to problems or even definitions and semantics of what is testing. So our field is really, really, really very new. And the beautiful thing about that is that everyone in this room, everyone online who's practicing in this field is doing something that is unique. What you're doing is unique. There's no one else on the planet that has the same business, technical, organizational, or cultural context on your problems. And that, to me, is beautiful. It shows that we have to do a lot of thinking, look at different things from different perspectives, tackle new things all the time. It is not a repeat the same thing. What is it? What do they say? That rinse, lather, repeat, something like that, the shampoo joke. Not the same. Testing is also intractable. We've known that since the 1960s. Edgar Dijkstra is the pioneer of applied discrete mathematics to computer science. He solved, with computing, he was the first person to solve the traveling salesman problem, which is the core algorithm between software like Google Maps. So that's the guy, Edgar Dijkstra. Edgar Dijkstra also in the early 1970s invented modern structured programming, which is the basis for object-oriented development, which is the dominant paradigm for programming today. This guy's like a hero in the software engineering world. But he also studied testing. And when he studied testing, and he documented this so nicely, he said, testing can show the presence of a bug, but it can't show the absence of a bug. No amount of testing can show that a piece of software is bug-free. You cannot demonstrate that software is bug-free by testing it. We've known that since the 1960s. That's a truth about software testing. There's good and bad signs of that. The good sign of that is that there's always another way to test your project. There's always another way. I can guarantee you there's another way to do it that you haven't thought of that might be more valuable, quicker, easier, or more insightful. But the sad thing about it is you never can say, I'm really finished. So there's got to be trade-offs. There's got to be risk models, stuff like that. So in reality-driven testing, I try to ask people to take a look at these things so you know what quality is to your stakeholders. You have a good sense on that. You know what it means to be done, what it means to be finished. Maybe you even know what it means to be ready to start. I like to look at three other things. What has really changed? What are people really doing with the software? And what is the environment that the product is in? So I like to call that the real world. What is the real world that the software is going to live in? The real changes is something that I think is hard to teach and hard to express, but it involves what I call technical collaboration, where you have people who are the constructors of software. Maybe you might call them programmers. I don't know. I don't want to sort of suggest that they're just wearing one hat. But people who are constructing software should technically collaborate with people who are going to be testing the software. And in my view, this is hard to teach. Technical collaboration is hard to teach. It is not hard to teach collaboration in general, because the soft skills, the human skills, the people skills, the collaboration and communication skills are excellent and well understood. Social psychology can teach us all about that type of stuff. Organizational behavior can teach us all about that stuff. But it can't teach us how to debug and troubleshoot the software and how to work in the IDE without sweating all the time, and how to actually technically collaborate. If I don't have much time to get things done, I want to understand what has technically changed in the system. What has actually changed? So what's the real changes? I encourage people to be able to visualize this. The diagram of choice for me is the block diagram. A block diagram is actually a type of software, if you will, a visualization. The blocks are often rectangles, which represent process elements. The lines, they're called connectors, are relationships between process elements. You don't have to actually know what the relationship is. You just have to know there is a relationship and name the process elements. If you can draw a picture like this, a block diagram like this, if you can draw one, then you can talk to people about change. If you can't draw a block diagram or you can't have access to one, it's very difficult, in my experience, to talk about what has changed. If I have this picture, and I'm talking to the programmers in an agile planning meeting at the beginning of a sprint, we might say, hey, we're implementing this new story. It's a cool thing we're doing, but okay, well, maybe the block on the top that says report generator. Well, the report generator, we've got to rewrite the report generator. Okay, so that block is going to change. But we're only going to make a slight change to the ribbon procedure or whatever it is. All of the blue boxes in this picture are things that are part of the system under test that we could change. And the programmers, when they're deciding technically what they're going to do, can name them. They could point to a box and say, that box is going to change. And you as a tester then, if you have that knowledge, you can sort of say, well, okay, if I know what box is changing, maybe I can start looking at how that relates to what people do with the product. And I can basically ask the question for the object that's failing, what if the object fails during a transaction? What if the object fails? What if it's not accessible? What if it's busy? What if something's wrong? These are called failure modes. It's the blocks that fail. It's not the requirements that fail, it's the design that fails, right? So it's the blocks that fail. And so we can look at the blocks, and by the way, the term mocking, if you hear the term mocking a lot, mocking comes up. Mocking is basically taking one of those blocks and putting a pretend block in its place that somehow you can control the behavior of. So I urge people to learn the relationship between the blocks of their system and what people do with the system. And if you don't have much time and you're under the pressure of a typical testing project, talk to the programmers, take a look at what's changed, maybe even classify it. This is a light change, this is a big change, all that stuff. And try to find what the relationship is between the usage scenarios, who is the user, what do they do, and the box that changed. So this is from something that's called a failure mode and effect analysis. And what's beautiful about failure mode and effect analysis is that non-technical executive stakeholders from all sorts of disciplines actually use this in other fields of endeavor, not just software. This is used in the automobile industry a lot. This is used in the airline industry a lot. You can get books on this type of analysis. I'm not saying to become a guru in it, but it's a simple thing is block diagram, what blocks are changing, how much are they changing, and how does that impact usage of a system. With that knowledge, you can focus your testing a bit better, and it's based on reality. Then the question is, what do people really do with the system? What do people really do with the software? I would suggest that when I'm working under pressure and I don't have much time, it's probably more important for me to understand who are the users and what do they do. Respectfully quoting the famous American President John Kennedy, he said, "Ask not what your country can do for you, ask what you can do for your country." Okay, patriotism, American stuff, all right, yeah. I'm a Canadian. I have to sort of be respectful of our neighbor to the south. If you know geography, you're laughing at that. That's great. No one in the history of the joke got that joke. Okay, so instead you paraphrase this by saying, ask not what your system can do for the user, ask what the user does with the system. Who is the user? What do they do? Don't model the software, model the user. Totally different paradigm. Make it real. Can the user do their job? How do you classify the job? What is the job? Let's learn about that stuff. We can identify categories of users and all sorts of scenarios. We can use storyboarding to visualize this. It doesn't have to be complex. It doesn't have to be a formal UML model. It could be. I love UML, but I don't want to suggest you learn UML. Learn a modeling method. Comic books are great, that style. But if you're familiar with comic books, I'm talking about like Batman, Superman, not Asterix, Tintin, if you know the distinction between the different comics. Okay. If you start looking at what people do with the system, you might find something interesting, is that not all activities are done at the same sort of frequency or cadence or distribution. And there's a type of analysis which helps me called a Pareto analysis, where we try to identify, from looking at past usage history of a system, we try to identify what the relative frequency is. So you try to identify, for example, what are the 20% of the transaction types that happen 80% of the time. That's the 80-20 rule. That's the Pareto principle. That's really helpful when you're under the gun and you want to do something like, oh, I don't know, build regression confidence. And regression confidence might be part of your, are we there yet? I want to be confident I didn't break something. Regression confidence, to me, is a warm, fuzzy feeling in my tummy. That's why I have such a big tummy. I love regression confidence. And when you get in there, my wife asked me to wear this jacket because she didn't want you to see how big my regression love is. But look at automation engineers from a different perspective. So what was I talking about? Was it software testing, Romania, get all this stuff. So anyhow, you're looking at identifying the sweet spot, the 80-20 rule. What are the most frequent transaction types? If you have that information, regression confidence, test the 20% that happen all the time. You'll build confidence that normal things work normally for normal people. It's not saying I tested everything, but if you can't test everything, maybe that sweet spot is a good starting point. Certainly, if that sweet spot fails, you found an important problem. Story. This is a campfire story. I don't want to sort of spend 2 hours, but I once did a keynote. That was the only slide, and that was a challenge I was given. It's a true story, but it takes me longer to tell that story than I have right now, so I won't tell that story. Instead, I'll mention something that happened in Chicago. This customer of mine had a system with 60 different features, 60 different screens. And they basically found out that they had a serious failing in cross-feature interference. So feature A was interfering with feature B. In consulting with them, they suggested, after learning the nature of the problem, that they should try to exercise all of the permutations. In other words, they wanted to test all possible operations in every possible order at least once. So with 60 items, right, you end up with 60 factorial. This is just the basic permutations, which is a nice small number, 8.32 times 10 to the 81, which according to NASA scientists, thanks to the CAST conference, I got to meet a lot of them in the Space Center near Paul's house, That's why Paul lives there, by the way. He wants to attest to this. There are, according to NASA, physicists between 10 to the 79 and 10 to the 81 atoms, 82 atoms in the visible universe. That's the number of atoms in the visible universe. So my customer wanted to do more tests than the lower bound on the number of atoms in the visible universe. But they said they had some automation that might help. Still laughing, that's good. I like that. So instead, I suggested maybe there's another way to look at this problem. Maybe we can look at the problem by looking at pathways through a system and studying how the system is used, what is the workflow of the system. And it turned out that they had a whole training department whose life mission was workflow. So I got from them an actual workflow diagram of the system under test. And from that, I created, this is a digital photo of the actual diagram I made. This is a control flow diagram visualizing the workflow of this customer problem and using a McCabe algorithms as published by Lee Copeland in his book, A Practitioner's Guide to Test Design. I didn't invent the algorithm myself. It came out with 22 tests. Now, this system had 22 pathways through it that were called the basis paths. My customer tested these 22 pathways. It was hard. It took 3 weeks. They had to create the data, they had to generate the transactions, they had to walk through them, and when they did, it failed miserably, and they had to organize it, fix the bug, and redo it. And then after 3 weeks, they were able to go into production with no further software engineering changes. What we're doing here is just making things real. The permutation thing, that's not real. The workflow, that's real. The pathways through the workflow is a test design technique. But you got to look at what is the workflow so you can do that analysis. And that's what I did. So the other one is the real world. The real world is the environment that your software is running in, including all sorts of stuff. The real world, things like who's paying for the software is in the real world. Are there other pieces of software running at the same time? This is the real world. It's not just what is the browser, although that's part of the real world. There's a lot of elements, a lot of factors to what is the real world in a system. Data sharing. I've had cases where all of the testing was done in a controlled environment, and then they went to production, and it choked because other applications were sharing the data, and they never tested for data resource contention problems and stuff like that. So we have basically all sorts of reality questions that we can ask, and once we've got these narrowed down a bit, we can sort of say, okay, I now have knowledge of what has really changed. I have knowledge of what people really do, and I have knowledge of what is the real context that the application is going to be running in, and that, to me, becomes the basis of my test ideas, not just the state of a stupid ticket in a workflow management system. There's a lot of ways you can implement this, and I'm not going to say anything against the workflow management companies, but I'm mad as hell, and I'm not going to take it anymore. So one tester at a time, one keynote at a time, I will help hopefully influence a different type of thinking in this area. It's also important, just to add a couple of things, don't forget, we still need to know acceptance criteria. So you still need to know things like what does it mean to be done and what does it mean to be ready. This is an important thing. And its question is, what do you want to call that? Do you want to call that testing? Do you want to call it requirement engineering? Do you want to call it project management? It doesn't really matter. It's just an important thing we need to know. We need to have in our sort of knowledge set when we're coming up with our test ideas. Risk models are also important. There's certainly people who talk just about risk models and spend days and days pointing it out. It is an important thing to have a notion of a risk model and not just make it up yourself, but basically work with your team to find one that's relevant. It's a little bit of a scope for my talk now, but that's an important thing you need too. And that's it. That's my stuff. So I did want to continue because I brought an analog clock around here with me. I don't know if you've ever seen one of these. It's really, really awesome stuff. And Paul told me when the big hand hit the 7 that I should go to questions. So Paul, the big hand?
The big hand is at the 7.
There you go. Thank you, guys.
Mike, can you, if anybody dares to put up their hand, I know we're in Romania, but means you have a question. If anybody online, there's no one online. Who's asking a question yet? But does anybody have a question for Rob?
There we go. Any questions in the room?
Those 5 slides you just fired through at the end and didn't let us read, I'd like to see those. Anything like that? That's a valid question if you wanted to ask that.
Any hands up for any questions?
Aha! Hype!
Wow.
I got it. I win.
You're the man.
So what you're actually saying is that us, the testing industry, needs to up our games in modeling, test design, risk analysis, test strategy, those kind of things? Is that what you're saying?
I wish I could be so succinct, and thank you for that very, very wonderfully phrased question. And it's pretty important for me to discuss upping your game. I think that's true. I believe in the model of the Swiss Army knife. So where I want a tester to have a Swiss Army knife with a lot of different blades that they learn the skill to choose what's the appropriate blade at the appropriate time. And that includes exactly what you talked about. So modeling, yes. And not just have one modeling approach, have many. And the one I'm exposing you to is failure modes. Look at failure modes. It's a fantastic way to identify things that can break. That's modeling. Then there's test design. I showed you control flow analysis, workflow analysis. That is test design. Learn as many test design approaches and master them. And with every project, get better and better. And don't just get stuck on that stupid test design technique you learned 23 years ago. You know, I meet people all the time who say, hey, I've got 20 years experience testing, and you look at it, and it's like 1 year of testing 20 times. It's because they're just doing the same thing over and over again. So learn new techniques, and then, to your point, master them, and that's upping your game. Yeah, do that for sure. Also, risk modeling is part of that too. Don't just have one way to do it. Have a few ways with your teams to get that going. Technical collaboration is also part of it. Learn to work in the IDE with the developer. You do not have to be a programmer to help debug and troubleshoot code in an IDE. Does that answer the question? Great question.
Great question. Any other questions? Way at the back, Mike.
Got you. I'm right here.
Hi, I was wondering if it would be possible to insert, like, for example, that block model into Jira or other tools that we already have to sort of merge the whole workflow idea with the reality idea.
I think that the question relates to, can I merge the workflow with the reality? Yes. I'm happy and delighted about workflow systems. Remember, I ranted about, in the year 2000, loving Jira. As long as the workflow system is supporting your work and your work is not supporting the workflow system, right, you're okay. You can break this down very gracefully. You can, for example, design a ticket for a user story and then a subtask for a testing idea, and then break that down into subtasks, which I might call charters, or I might call test goals, specific things I want to learn about, and I would break that down. So I can decompose my models so that it is really reality focused, but it comes down to what is the actual technical work that we've got to do it deliberately, and make sure your model of workflow allows for you to build that collection of real test ideas, test activities. And if you want a trick to doing this, just one of the tricks I love to use, especially as a consultant, is to basically, when I'm describing my testing work, never use the word test as a verb. I always describe testing work based on what I want to learn about. I never say an activity saying test this feature, because if you said that, you're not saying anything to anybody. But if you say, I want to learn about how this business rule works in this condition, now you're saying something. So I describe testing tasks and activities based on what I want to learn about, and I try to avoid using the word test as a verb. Did that answer the question?
Yeah.
That's a very important thing. You can definitely use tools like Jira or DevOps, Azure DevOps, things like that. They're great tools, but make sure that it supports your work, not the other way around.
Mm-hmm. Thank you.
Thank you.
So while Mike meanders to the back, we have an online question. How is reality-driven testing different from context-driven testing? How is reality-based testing different from context-based testing?
Well, I would say that context-driven testing is a broader concept, and that the reality stuff is a proper subset of it, I think, in my experience. I don't think that we have a consensus onto what the definition formally is of these things, but I do believe that it's a subset of it, and it's everything that I do and talk about is generally classified as context-driven testing. I don't know if someone here knows more about the terminology in that than I do. So reality-driven testing is just, yeah, for me, it's part of context-driven testing, but there's a lot of context factors that I don't necessarily have a slide about. Like, do I have a slide in this deck that says identify context factors and do context listening and stuff like that? Sometimes I basically say I'm going to go meta on that. I'm not going to include that in my day-by-day testing model, but it is important that you be sensitive to business, technical, organizational, and cultural factors that drive decision-making in your projects. And reality-driven testing is very much that. So it is part of context-driven testing, in my opinion.
Thank you.
Hello. Okay. My question is difficult for me to ask, but I will try to make it simple. I'm afraid that if we're performing the testing in this way, we're going to lose our jobs. And
We're going to what?
we're going to lose our jobs as a testers. And why I'm saying this, I'm struggling now with this situation. I mean, I'm asking my team and my product manager all these kind of questions, and I'm trying to understand the risks, what matters to our stakeholders. I'm trying to model the system. I'm trying to diagram a lot of ideas, and they had this, let's say, illumination. Oh, this is what we were missing. We were missing a business analyst. Oh, I will going to make you a business analyst. So my question is, how can I, as a tester, keep my job doing this kind of analysis or risk analysis or reality-driven testing, being a tester, and convince my manager that this is the proper way of doing the tests?
We can discuss in detail offline many threads in that area. I don't ask anybody to risk your job or risk your career. I want to implement organizational change, and you are an influencer of organizational change, whether you know it or not. And you are a very important person in that organization. If you want to start introducing a concept based on something we talked about, I would usually look at what is the problem I have to solve, and then suggest that something in this might help us resolve that problem. For example, if you're worried about reducing bug escapes from production, you can show how failure mode analysis can help you do focused regression testing, which will take less time to test and will help you reduce that type of bug in production. If you are worried about time to get things done, modeling how the users use the system might be a lot easier or a lot more time efficient than modeling what the system does. And I've got case studies and examples documented where we look at systems where you had hundreds of menus and dialogues and controls, but only 27 usage scenarios. There's a project I'm working on right now in medical clinical trial system where we have actually 30 usage scenarios and something like 300 pages of controls that just don't make any sense to anybody. So by looking at the different perspective, we have an economic advantage we can give to the company. We can show the people that this is a more economic way to do things. And if there's no benefit for it and you try to make the change, then yeah, it's hard to sell that. So I wait for the opportunity, I try to figure out a baby step that has some sort of benefit, and I demonstrate that, and progressively I can influence change. However, I must admit that I do not ask everybody to go and put yourself in a job-threatening position. I really feel that that's unfortunate I don't doubt that's true, by the way, in many cases. I'm sure that you've all seen and heard people who have gone through terrible experiences like that. But if you can show that there's going to be a benefit by looking at this reality stuff as opposed to just following the ticket system, you might get buy-in from your stakeholders. I think that's all I want to say right now about that. That's a very big and very important topic, though. And glad to jam more offline about that.
Thank you.
Thank you.
I'd like everybody to thank Rob for that great keynote.
Thank you.